So, um, so my name is David Mentre. I'm part of Mitsubishi Electric R&D Center Europe in Rennes, in France. My background is more in computer engineering and telecommunication engineering. And I've done some work in deep packet inspection, protocol verification, and so on. And since 2009, I'm working on formal methods. So formal methods for safety, but also for security, applied to several domains, like railway, but also factory automation, automotive, or other domains. So what is the current situation in railway domain, in railway systems? I'll go very fast through these slides because it has been repeated several times up to now. So railway systems have been designed in safety mindset. So safety first, where systems should handle all possible kind of errors, as Mr. Fadin said, physical errors or logical errors, like design or programming errors. So we have well-known standards that are well-known and well applied among industry. Up to now, until very recently, it was a closed system design approach, where technology details were only known by a few experts. There was no communication or only private isolated networks, so the system was closed to the outside world, and security issues were not considered, as it was said. And of course, in a railway, we have a lot of legacy and very long-term maintenance systems. For example, some systems are 100 years old. For example, some switches in Paris or Strasbourg. And so some global systems are made of very old and very new systems interfacing each other. So when we need to consider such systems, we need to consider the maintenance of such systems over a very long lifetime. So what are the challenges? Things are changing a lot, as we said this morning. For example, systems are computerized a lot of more nowadays. Systems are interconnected, so we have different edges, different providers, operators, different networks, different technologies. We are using more and more components of the shelves. So regular computers, for example, in railway systems. So if we have a Windows operating system to control a railway network, what happens if there is a malware on the Windows system? We have Wi-Fi for subway, GSM-R for ERTMS, and so on. And technology nowadays is known by a lot more people, not only experts. So for example, you can find open source projects to build a GSM base station or a mobile GSM mobile. So it's very easy for somebody to build a false GSM-R station, for example. You have open source for protocol stacks and so on. And technology evolves very quickly and spans wide domains. So for example, as I said, the issue of maintenance, for example, can the current switching system can be maintained in 10 years from now? And the main issue is that engineers need to understand and be up to date to several security and technology domains. And it's very difficult to know every security and technology domain. So, what are the security challenges? As Mr. Fadin said, no system should be also designed with a security mindset. So in the security mindset, as several people say, it's not the security of the whole system, it's the security of the weakest link. So we should protect against not only errors, but deliberate attacks. So attackers, they know your system, they know your network, or your hardware, your protocol stack, and so on. So you cannot have the assumptions that your system is unknown to the attacker. The first hypothesis is that the attacker knows perfectly your system. And the attacker also has plenty of resources. He has knowledge, time, CPU, so he can attack everything. You can attack computers, from switch to computers, Wi-Fi or cellular networks. So GSM-R, it's possible to build a false GSM-R station. From serial buses to IP networks, or field sensors to GPS positioning. In the literature, you'll find papers how to modify the positioning or influence the positioning of GPS stations. So, as an engineer, it's really a nightmare. I agree. So, as we said, attacks can impact availability, but also safety. For example, if you can change the firmware of a CBCC train, will it stop before its movement? Of course, this kind of problem is not only railway specific, but also in other domains like automotive, factory automation, or aerospace. So, what are the responses? I will go through two possible responses. The first one is new standard for security or mixed safety and security. So I won't go through all those standards, just to say that we have security-specific standards, railway-specific standards on security, but also the same in automotive or aerospace. So those standards nowadays are not well known and not widely applied, but consciousness of those standards is increasing a lot nowadays. And as Mr. Fallin said, you guys will help understand better those standards. But you also have new tools, or old tools used in a new way, formal methods. So formal methods are the use of mathematics to check exhaustively a property on software, hardware, or system. So formal methods are widely known and used in railway for 30 years or more now. For example, back to the SACEM system in France, line 14 Paris Metro, or switching system all over Europe. But the target of formal methods up to now was safety. So all the methodologies, the tools were organized around safety. But such tools can also be applied to security. So here is a simple example. Imagine you have a legacy system, and you want this legacy system to communicate with IP networks, other system, open networks. So you insert to it SSL TLS stack to authenticate your users. So you buy some TLS stack on the market, or you integrate an open source code. But how to be sure that you are not integrating possibility at new attack surfaces in this TCL SSL stack? A company, TrustInsoft, is providing freely on the web, for example, a verification kit for a specific TLS embedded, called ARM embedded TLS or Polar SSL stack. So using this kit, you can be sure that for a specific configuration of this TLS stack, it's not possible to have any runtime error. So you are immune to any buffer overflow, integer overflow, out of border access, division by zero, and so on. And this report is building on both review and formal verification on the source code. And this formal argumentation is using TrustInsoft Analyzer as a tool. So this is just one example to illustrate that nowadays on the market you can find ready to use formally verified protocol stack or tools. To go a bit deeper, here I've listed several kinds of formal methods that could be used for railway specifically for security. So you can use abstract interpretation technique. Those techniques are used mostly to verify, mostly automatically, some simple code level properties, mainly that you don't have runtime errors on C, C++, or A code. For this, you have several commercial tools like TrustInsoft Analyzer, Matchworks, Polyspace, or Absent Asprey tool, for example. You also have deductive verification. Here you can prove properties for each program function, or it's much more labor intensive, so should consider using it or not. So you can prove absence of runtime error, but the functional properties, for example, can prove that some software will always respect a security policy. So you have Adacor, SparkTool, or Pharmacy, WP open source project. You have also certified protocol stacks. So those protocol stacks will ensure you that the protocol stack will never go in a bad state. So that the protocol can never be misused to attack your system. Those projects are more research projects or advanced projects and they are not really yet to be used as a commercial product. But they nonetheless exist and will probably produce commercial projects in few years from now. Then you have certified operating systems. So certified operating systems are just like regular operating systems, but they provide you, they ensure you some safety or security properties. For example, they ensure you, they prove you that they will always ensure process isolation. So for example, if you consider this setting, you have a regular operating system, for example, a Linux system used for the multimedia within the train. And here you have the proven operating system used for safety critical or security critical tasks. And this operating system can ensure you that the multimedia operating system will never impact the safety critical or security critical parts. So you have several commercial offerings like Proven Run, Proven Core, SCL4 microkernel, or something. And last but not least, you have also automatic testing tools. So, of course, you can keep the usual testing process, but Security World has produced a lot of security-specific testing tools to try to attack your software. For example, FALFers or password tools. So, what are the advantages of formal methods? Formal methods bring exhaustive verification. So, it's crucial for security as it was crucial for safety up to now. And because, as I said, the weakest link can be the attack of your whole system. Formal button brings easy way to replay verifications. When we speak of maintenance, the issue is not to make a safe or secure system, but to make a safe and secure system over 10 years or 50 years. So you need to replay, to recheck that the system is still safe or secure. And using formal method, it's much easier to replay and recheck everything. And several of those tools are open source, so now it's much easier and less costly to test them and integrate them within your development process. To conclude, security issues are not pervasive in railway systems, so there is a need of security mindset in addition of the usual safety mindset, and there is an interrelation of safety and security. Security of the system is security of the weakest link, so we need to apply security in depth. So we rephrase Marc Anthony speech. And we need new methodology, new security standards, or at least to apply those security standards, and new tools like formal methods. Formal methods can help because they verify exhaustively a property, so they can bring you very strong guarantees on the security of your system. Of course, they are not the silver bullet, and as for SIL4 system, you need to apply formal method only on the specific part, relevant part of your system, depending on the security analysis of your system. So you need to target the best security balance and return on investment. And you have several commercial offerings with extensive support, which is usually an issue with formal methods. So companies like Adacor, Matchworks, Proven Run, TrustInsoft, and much others are providing nowadays on the market tools and support to apply those tools on your own. I've now finished my presentation. Thank you.